So in this FRQ, it shows 3 circuits, and the question says, in the 3 circuits shown above, the batteries are all identical and the light bulbs are all identical. In circuit 1, a single light bulb is connected to the battery. In 2 and 3, 2 light bulbs are connected to the battery in different ways as shown, and the light bulbs are labeled A to E. So first, I just drew this out on paper in a form that we can more easily recognize, and all the batteries I labeled with the same voltage V, and circuit 1, as you can see here, it has 1 light bulb, which is 1 resistor, and you can see that here, so I labeled this resistor A. Circuit 2 has 2 light bulbs in series, and you can see that here, resistance B and resistance C. And finally, circuit 3 has this parallel part, and I drew that here, resistance D and resistance E. So A asks us to rank the magnitudes of the potential differences across light bulbs A, B, C, D, and E from largest to smallest. And if any light bulbs have the same potential difference, then we're supposed to state that explicitly. And my ranking here is RA is equal to RD, which is equal to RE, which is greater than RB, which is equal to RC. So the way I found that out was that since all these voltages are same, you know that the voltage or potential difference is the same as voltage. So the voltage across this resistance has to be equal to this because there's only 1 resistor here. So RA's voltage is just V. And in circuit 3, it's parallel, and you know that in parallel circuits, the voltages stay the same. So RD and RE's voltages are both V also. So that makes this V, V, and V, which is equal. However, this is a little bit different because they're in series, and in series circuits, the current stays the same, not the voltage. So you know here that resistance B and resistance C have the same current, but that means that they have less voltage. They have to split V equally across each other. So both of these resistances have voltages of V over 2. V over 2, this makes this equal to each other, but less than this. So this voltage is V, and this voltage is V over 2. And B asks, the batteries all start with the same amount of usable energy, and all are connected to light bulbs in the circuits at the same time. So basically, these batteries all have the same voltage or same energy, and the equation I'm using now will be power equals V squared over R because we know what V and R are. They're just V and R. And so it's asking for which circuit the battery will run out of energy first and what circuit the battery will run out of energy last. So looking at this equation, we can solve for power in terms of V and R for all the circuits. For number 1, the power will be just V squared over R, which is easy. Number 2 is, since the voltage of these are both V over 2, you have to do V over 2 squared over R for each one and add them up, so that's equal to 2 times V over 2 parentheses squared over R, which is equal to V squared over 2R. Finally, for circuit 3, since the voltage for these are both V, so you have V squared over R for this, V squared over R for this, and you add them up and you get 2V squared over R. And then, since energy is in terms of power over time, or since watts is equal to power over time, the energy, since energy is joules and power is joules over time, energy is equal to power times time. So the unit will both be joules. And then you can rearrange this to become time is equal to energy over power, which means the bigger the power, the less time it will take for the circuit to run out of energy. So the greatest power will run out first. And you can see here that number 3 has the greatest power. So 3 runs out first. And similarly, the one with the smallest power will run out last. So number 2 will run out last. And that's it.